Every year, 4 million people visit Yellowstone National Park. They photograph the geysers. They watch the bison. They buy the magnets. And then they leave, completely unaware that they spent 3 days standing on top of one of the most dangerous, bizarre, and scientifically bewildering places on the surface of this planet. This is what they don't tell you. Yellowstone sits atop a supervolcano. And not just any supervolcano. One of the largest active volcanic systems on Earth. The magma chamber beneath the park stretches roughly 55 miles long, 20 miles wide, and sits just 3 to 10 miles below the surface. For reference, you could fit the city of Los Angeles inside it, with room left over. But here's what most people don't grasp. The last time this system fully erupted, 640,000 years ago, it released 2,500 times more material than the 1980 eruption of Mount St. Helens. It buried half a continent in ash. It temporarily altered the Earth's climate. And the system beneath you right now? It's still very much alive. Scientists at the USGS monitor over 3,000 earthquakes in the Yellowstone region every single year. Most are too small to feel. Some are not. In 2017, a swarm of 2,400 earthquakes hit in a single 3-month period, the largest earthquake swarm ever recorded at the park. The ground rose and fell by inches. Geologists watched. The world mostly didn't notice. And yet, the park stays open. Because the odds of a full eruption in any given year are roughly 1 in 730,000. Probably fine. In the northwest corner of Yellowstone, there is a 50-square-mile strip of land that straddles the Idaho-Wyoming border. It's inside the park. It's beautiful. It's remote. And according to a legal loophole that has never been fixed, you can commit any crime there and never be prosecuted for it. Here's how it works. The Sixth Amendment guarantees the right to a trial by jury. Juries must be drawn from the state and the district where the crime was committed. The Idaho portion of Yellowstone sits in Wyoming's federal judicial district. But Idaho residents don't serve on Wyoming juries. Wyoming residents can't serve on Idaho juries. The result? There is no pool of eligible jurors. No jury, no trial. No trial, no conviction. Michigan State law professor Brian Kalt identified this loophole in 2005 and published a paper about it, partly hoping Congress would close it. Congress has not closed it. The zone of death still exists today. To be clear, we're not saying anyone has used this loophole. We're just saying someone could. The colors of Yellowstone's hot springs look like they were designed by an alien. Vivid turquoise cores bleeding into rings of gold, orange, red, and brown. It's the kind of palette you'd expect from a science fiction film, not a national park in Wyoming. So what's actually causing it? The answer is extremophiles, microorganisms that should not, by any conventional understanding of life, exist at all. The deep blue center of Grand Prismatic Spring reaches temperatures of 189 degrees Fahrenheit, near boiling. Almost nothing survives there. But as the water radiates outward and cools, microbial mats begin to form. Different species colonize different temperature zones. Each species produces its own pigment, and together, they paint the rings. The orange and yellow rings are largely archaea, among the oldest life forms on Earth. These organisms don't just tolerate extremes, they require them. No oxygen, no moderate temperatures, no normal chemistry. NASA researchers have studied Yellowstone's hot springs as a model for what life might look like on other planets. If microbial life exists on Mars or beneath the ice of Europa, it may look, biochemically speaking, a lot like what's living in these pools right now. The colors at Yellowstone are not just beautiful, they're a preview of what alien life might look like. Old Faithful, the most famous geyser in the world, the park's signature icon. And almost everything the average visitor believes about it is slightly wrong. First, it's not the biggest. It's not even close. The park's steamboat geyser, when it erupts, shoots water over 300 feet into the air. Old Faithful tops out around 130 feet. Second, it's not the most regular. Old Faithful's eruptions have been drifting further apart over the decades, from roughly every 65 minutes in the 1950s to an average of 90 or more minutes today. Some researchers link this to major earthquakes far away, including the 2002 earthquake in Alaska, after which Old Faithful's interval measurably changed. And third, the most interesting part, how do geysers actually work? The system beneath Old Faithful is a precisely shaped underground plumbing structure, a narrow vent that allows water to superheat under pressure without boiling. When enough pressure builds, water at the top of the column boils first, releasing pressure, which causes the water below to flash boil almost instantaneously. The eruption isn't an explosion. It's a chain reaction, a thermodynamic cascade. Old Faithful is predictable because its underground structure is unusually stable. But if the 2002 Alaskan earthquake could alter its rhythm from 1,400 miles away, what might a local seismic event do? Nobody knows. That's the honest answer. In 2014, a viral video appeared online showing a herd of bison running away from the center of Yellowstone along a road toward the park exit. Social media erupted. Were the animals fleeing an impending eruption? Seismologists checked. There had been a minor earthquake swarm. Geologists said the animals were probably just running. Bison run sometimes. That was the official explanation. But the question the video raised is actually scientifically legitimate. Can animals sense geological events before humans can? There is documented evidence from earthquakes around the world of unusual animal behavior in the hours and days before a seismic event. Snakes leaving burrows in winter, fish surfacing en masse, dogs and cats becoming agitated. The mechanism isn't fully understood. Some researchers point to ionized particles released from stressed rock before a quake, particles that some animals may be able to detect through their sensory supers. Yellowstone's bison herd has lived above an active volcanic system for thousands of years. If any animal has had time to develop a sensitivity to what's happening underground, it might be them. We like to think we have the best sensors. We might not. Yellowstone's ground is not still. The entire caldera, an area roughly the size of Rhode Island, is constantly rising and falling. Scientists call it caldera breathing. Between 2004 and 2008, parts of the park floor rose by nearly 10 inches in just 4 years, the fastest rate of ground uplift ever measured at Yellowstone. Roads buckled. The famous boardwalks had to be re-leveled. Then, just as mysteriously, the ground began to subside again. This rising and falling is driven by the movement of hydrothermal fluids and magma beneath the surface. The system is dynamic in a way that's genuinely difficult to predict. And Yellowstone Lake, the largest high-altitude lake in North America, sits directly over part of the caldera. Its floor has its own underwater hot springs, its own geothermal vents, and its own system of ridges and domes that shift and swell over time. One dome beneath the lake, the Fishing Bridge Dome, grew nearly 100 feet in height over a span of roughly a decade before deflating. On the surface, the lake looked perfectly calm. In the 1800s, explorers found something strange in Yellowstone. Small depressions in the ground, mostly forested, mostly quiet, filled with the bodies of animals: bears, birds, squirrels, deer. No visible cause of death, no wounds, just dead. These are called asphyxiation pits, or, more colloquially, death gulches. They're found in areas where geological activity pushes volcanic gases, particularly carbon dioxide and hydrogen sulfide, up through the soil and into low-lying areas. Carbon dioxide is heavier than air. It pools in depressions, invisible and odorless in the field, and quietly displaces the oxygen in the breathing zone of any animal that wanders in. One such site near Cache Creek was documented in the late 1800s, containing the remains of over 20 bears, along with numerous smaller animals. Naturalist C. Hart Merriam described it as a charnel house. The park does not broadly advertise the locations of asphyxiation zones. Most are roped off or unmarked. Hikers off-trail could, in theory, walk into one. Another reason the boardwalks exist. We've mentioned the extremophile microorganisms, but the story of life in Yellowstone's thermal features goes even stranger. In 1966, microbiologist Thomas Brock discovered a bacterium living in Yellowstone's Mushroom Spring at temperatures above 160 degrees Fahrenheit. It was named Thermus aquaticus. At the time, it was considered a biological anomaly. Life simply wasn't supposed to survive those conditions. Yellowstone National Park is, on the surface, a place of extraordinary beauty. Hot springs, wildlife, wide open skies. But beneath that surface, sometimes just miles, sometimes just feet below where you're standing, is a world that is alien, volatile, ancient, and barely understood. A supervolcano breathing slowly. Microorganisms that shouldn't exist, teaching us what life on other planets might look like. Ground that rises and falls like a living chest. Legal dead zones. Invisible death traps. A bacterium that changed medicine forever. Most visitors see the postcard. Very few see the park. Now you do. Thanks for watching. If you enjoyed this video, please like, share, and subscribe. This has been National Park Mysteries.